We got quiz number 5. Quiz number 5 says we have proton moving along the positive y-axis. We're going to call it north at 5.05, providing off-center with the stationary alpha particle. This is like a combination of two questions that we've done before. One, that curling question, right, where the curling rock was going north, and then glancing collision, one went one way, one went the other way, and a practice quiz question we had where we had the proton and the alpha particle. We have the data for the proton and the alpha particle on our data sheet, so we can get those masses on our data sheet. And as far as the rest of it goes, treat it like the curling question. First thing we do, draw a picture. When we see a north, a west, and a north in the same question, we know this is going to be an x and y component problem, right? Draw a picture so that we can get those x and y components here. I'm going to say object number 1. I'm going to call that the proton. It has a mass of 1.67 times 10 to the negative 27 kilograms and a velocity, a speed of 5.05 times 10 to the 7 meters per second. And it's heading upwards. Positive y-axis or heading to the north. Object number 2, which is our alpha particle, has a mass of 6.65 times 10 to the minus 27 kilograms. And it has a velocity of 0 meters per second, at least initially it does. Now this question tells me that the proton goes off at an angle right here of 30 degrees west of north. We've got to make sure that we label that from the north, not from the west, but it is west of north. I'm not going to label the mass there again because I've already got that, but the speed of this would be 3.5 times 10 to the 7 meters per second. Now it stands to reason that the alpha particle is going to go up here somewhere. We don't know where exactly, but somewhere in that quadrant, right? Now, what do we see here? Funny angle. And when we see a funny angle that's not 90 degrees, what do we think? I don't like funny angles. So let's take that funny angle off to the side, right over here somewhere, label it 30 degrees, 3.5 times 10 to the 7 meters per second, and then let's draw in our x component and our y component. And let's solve for that x component and y component. Now, we ran across this a couple of times over the last few days. Usually, x goes with cos and y goes with sine. But that's only if the angle is measured from the x-axis. Here it's measured from the y-axis. So if we look at this closely here, the x component is the opposite side of the triangle. Therefore, we're going to use the sine function. Sine 30 degrees is equal to opposite over hypotenuse. That gives us a value of 1.75 times 10 to the 7 meters per second. Now, the adjacent side of the triangle is the y component. So we're going to say cosine 30 degrees is equal to y over 3.5. The y component, when we do that, works out to be 3.031 times 10 to the 7 meters per second. I want to box that off. How come? Well, because that's what I do. Structure. There's value in structure. Now, let's replace this 30 degrees and 3.5 value over here, because, look, that was the whole point of resolving it into x and y components, to get rid of it, so I never have to see it or deal with it again. Let's draw in x was 1.75 times 10 to the 7 meters per second, and let's draw in y 3.031 times 10 to the 7 meters per second. Now, let's do our thing. If we had the angle of the alpha particle, the angle of the final velocity of the alpha particle, that would be one of those problems given the angle. We could do one component or the other and then take a shortcut, right? We don't have that here, so we have to do this the long way. We got to do both x and y components. So let's start with x. X is the one that I like, because you can see here that object number 2 isn't moving. Object number 1 is moving, but it's on the y-axis. So that means the total initial momentum for the x component will be 0. The final momentum will be m1v1f plus m2v2f, because there's two objects after this collision takes place. Now, I'm going to say mass 1, the proton, the mass of the proton, I'm going to say is 1.67. Okay, when I did my answer key here, I just dropped the 10 to the minus 27. How come I did that? Yeah, It's all the same exponent, therefore, and it appears in every term, so I can cancel out that exponent if I want. You don't have to. It just saves me a little bit of work on your calculator if I drop the 10 to the minus 27. I don't want to drop the 10 to the 7 with the speeds because I'm trying to find speed. If I drop the 10 to the 7, I'm going to get confused when I get a final answer for speed. So if you're confused about that right now, don't drop anything. Don't cancel anything. Because it always works if you keep all of the number there. Okay, so this is 1.67. The x component of object number 1's final velocity is negative 1.75 times 10 to the 7 meters per second. M2, this is the alpha particle, but I canceled the 10 to the minus 27, so it's just 6.65 times V2F. Now, I'm going to just in an effort to save a little bit of time here, I'm not going to go through this on my calculator. If you have trouble getting the answer that I'm going to get here, just stick around for a couple minutes at the end of class and I can go through that with you. When I solve this on my calculator, I'm going to get V2F is 4394736.842 meters per second. Then I do the y component, where once again I say pi equals pf. This time, object number 1 has an initial momentum because it's moving on the y-axis. Object number 2 is still at rest, the alpha particle, 2 objects afterwards. The masses don't cancel, but the exponents do. So I can say the mass of the proton is just 1.67. 5.05 times 10 to the 7 is my initial velocity of the proton on the y-axis. The proton again. The y component of the final velocity of the proton is my green one here, which is 3.031 times 10 to the 7 meters per second, plus the alpha particle times V2F. Now this one's a little harder to rearrange. I'm still not going to show you this on the calculator, just in an attempt to save a little bit of time, but I'll briefly point out what you do. Calculate that number, calculate this number, and then take this number over to the other side by subtracting, because it's added on the right-hand side. Then take this one over by dividing. And that should give you a V2F of 507020.677 meters per second. Now, we've got our V2F x and y. I'm going to redraw this. Here's x, 4394736.842. Here's the y component, 5070270.677. This is what I want to find. This is what I want to find, the hypotenuse, the resultant velocity. So I solve for that using the Pythagorean theorem. If there was a negative in there because it was left or down, we would drop the negative when we put it into the Pythagorean theorem. We don't have to worry about that in this one. We do that, we get 6.71 times 10 to the 7 meters per second. And theta is the inverse tan of opposite over adjacent. That gives us a value of 49.1 degrees, and this would be north of east. Had you chosen to draw the y-axis first and the x-axis, you would have gotten an angle, still the same hypotenuse, but you would have gotten an angle of, what would it have been, 30.9 degrees? 30.9 degrees east of north. Don't panic if you get the wrong answer here. You can still easily get a 3 or 4 if you get the wrong answer for this. But just be aware that on Tuesday, if you get the wrong answer for this, it's 0 to 1, right? But remember, usually on those multiple choice questions, they give us some sort of shortcut. So it's probably not going to take quite as long as this to answer. I didn't give you the shortcut on this quiz because I wanted you to know how to do everything. But if there is that shortcut, go ahead and take it. Sorry guys, correction. Everything is essentially correct here except for this should be 6.71 times 10 to the 6 meters per second, not 10 to the 7 meters per second. There could be rounding issues that you had throughout there if you didn't use unrounded numbers, or the same for me. But this is our method, and we should again get 6.71 times 10 to the 6 meters per second. The other angle we could have gotten would have been 40.9 degrees east of north. I think I had said 30.9 degrees. It would be 40.9 because we subtract this from 90, right, in order to get the complementary angle of that.